Just open there because now it shows that it's open. You open on the drive, right?
Yeah. You can copy that stuff.
I know, but the new file appears in the temporary one, so basically.
Oh, yeah.
I
just typing on the drive.
But the problem also, if you want to change your memory.
Well, no, actually, they're not. That opens from my local drive, so I don't know why it's.
Maybe you have it synchronized to that. Always on.
It must have been just syncing at that time.
Yes, new files are popping up while I was copying.
We'll get started in a couple of minutes.
Sorry? No, no issues. First one is can keep talking on.
Still missing us, people. Okay, let's make a start. Welcome back to NVO3. So once again, here is the notes well. Okay, blue sheets are going around. We have two blue sheets, one going down each side of the room. Ignis is taking notes again, thank you. Okay, so the agenda for today. So we met yesterday. We had quite a good session, a round table session, I think. So today what we're going to do is we've got a couple of presentations from Greg on OEM. And then we're going to have report backs from the 3 round table discussion sessions yesterday that were chaired by Benson, Pat and Greg.
Okay. Yeah, we can go to the next slide right away. Okay, so this is update. You may recall we had overlay OEM design team formed in the routing area and chartered to do work that would be applicable to new overlay technologies, including Layer 3 overlay, SFC, and beer. In Berlin, we decided that group achieved some result, and the group itself were all participants, well, they get their thank you, and formally group was closed, but we decided to continue work on 2 solution documents. One of them that introduces OEM header. Originally, and so this is just to give update on a new version. Originally, we had 1 word for overlay header, which had version number, message type, flags, and the length. But then in the discussion, it was too limited, so to have more space for new functionality, we decided to go for 2 words and not only expand message type, length, and flags and have a reserved field for future, but add a next protocol field. So, and that's something that definitely would like your consideration and invite comments about the idea of having the next protocol. So the idea is that OEM control packet can be followed by some other protocol, and it could be the payload. So thus you will get the functionality of what's characterized as in situ OEM. So you have OEM, and then you have followed by their payload. Or it could be something else. So in this way, this header can combine active OEM and in situ OEM functionalities. Well, we expanded use of timestamp in the timestamp block and detailed IANA consideration section as well. So these are updates in this version. So, as always, all your comments, reviews, suggestions, contributions are most welcome and greatly appreciated. As well, we will be presenting this update tomorrow at RTGVG, and just want working group involved to think where they think that this work can be continued for the benefit of everyone.
Okay, so I guess the question is whether or not it eventually gets adopted here or in, say, RTGWG as a generic.
Yes. So as I mentioned, so we do have two other informational documents. One of them being requirements, and another is gap analysis that addresses use cases, scenarios from all three technologies, NVO3, SFC, and the beer. I have to mention that in beer we do have working group documents already, but if there is agreement that these requirements and documents are something that we want to progress, we can work with the beer group that will concentrate on more generic solution rather than, and then whatever specific, because again, for the beer, for example, I can say that there is a document of path MTU discovery, which takes advantage of specific beer technology, which not be applicable to other scenarios. But we definitely would appreciate consideration and discussion about whether there is interest to continue this work on common OEM for all overlay technologies.
Okay, thanks. Can you ask a question? Oh, sorry, Lucy.
Lucy Yang from Huawei. Can you go back one slide? So this version you add the next protocol. Then assuming this next protocol, you can they call the in-band OEM. So you carry the OEM package with the payload. Also, you can be used for the out-band if this non-protocol.
Okay, about terminology. I would call it with in situ OEM because I really like this term, and active OEM because active OEM can be in band as well. If we and then in our discussion of what we had a discussion yesterday, we talked about it. So active OEM can be in band, which means share the fate of their data flow it's supposed to monitor. So I would not really refer to active OEM as out of band, because again, then it would not be really any use to have out of band OEM, because we want to interpret whatever we do, defect detection and performance measurement. We want to correlate it with their what experienced by the data flow.
Okay. So also this format, you have this flag field and also reserved field. So I'm just curious why you separate this.
Okay, that's a good question. Thank you. Originally, we took everything for flags, but then we decided, well, there is enough flags in this format, and reserved flag might give us some flexibility in the future. But if there are strong opinions that reserve field may not be needed, let's discuss it.
Yeah, I think a flag also just a field. You're not the fully defined it. So
yeah, but
the same
right. Again, in past experiences, it's possible to then redefine and merge reserve with the flags, but at the same time, reserve can be dedicated to something else.
Hey, Greg, Frank Brockners. So how would that fit into, so the new header format, how would that fit into something like VXLAN GPE? Would you propose this to be a new protocol header in VXLAN GPE, or how do you see it?
No, after. This, as described, again, yes, this is a update on version 0. So this is version 1 update. In the version 0, what we state that OEM header immediately follows their encapsulation header. So you have VXLAN GPE, which identifies the payload as OEM, and then you have OEM header, and then in OEM header you can identify the next type of the payload which follows OEM control packet.
Okay, thank you.
So that's a process request that will change processing. The flow will change. The typical OEM package you will through to the control plane. Now, if you have payload, you cannot do that.
Again, we are open to discussion, and we most welcome comments and consideration, of course. Yes, you're absolutely right. In the case of active OEM, when you have only OEM control message, it usually goes punted up. It could be just bumping the wire, or it goes all the way up in the stack. Depends on implementation. But the functionality characterized or functions described in situ, it is interest, and that's why there's proposal that can work for both, for active and for in situ, which might be interesting. Next.
All right. So who's read the draft? If you could raise your hand if you've read the draft, please. Okay. See a few more. It'd be good to see a few more reviews of the draft. So please read it and post comments to the list. Thank you.
Actually, if I may ask, because we'll be presenting tomorrow at RTGVG, and in SFC update, they have chairs put the reference to this. Perhaps we can just keep every group in a discussion, so might be at least people who are not in NVO3 will be interested and participate in discussion.
I wonder if the best thing is just to send the comments to RTGWG rather than cross-posting to lots
Okay.
of lists.
That works too. Okay, so the second document that we have update today is on overlay echo request reply. And so what, yeah, we can go to the next one. So what we updated is that we changed the terminology from overlay ping to echo request reply, because in many applications what we found, and one of the example is transcending traceroute, is effectively we are interested in, or maybe interested in querying information from the underlay. So request reply seems to be better terminology for that rather than ping. So expanded their request transmission session, security consideration for different types, and IANA section allocation. Can we go to the next one? Yeah, so for the security consideration, obviously because we are part on overlay network, so we inherit all the security consideration of the particular underlay and overlay networks. At the same time, so there are three types of threats that attack vectors that needs to be considered. And to mitigate these threats, so obviously, as usually in echo request reply, we recommend to do rate limiting on number of packets being punted. At the same time, there are some scenarios where check on a sequence number to verify the identity of the source is useful. To make it stronger, we recommend to use or optional use of timestamp block, which is defined in a header document in the previous document that I presented. Well, if need to be, then definitely it might need to have some encryption. Next document. Next. Yeah, and here's another just a question to everyone, because we thought of whether there is a traceroute scenario for overlay. In case of beer, which talks about intermediate bit forwarding routers, BFRs. So it's clearly identifies the need for the trace route. But what's interesting, whether the trace route in NVO3 overlay presents a scenario that needs to be addressed. And again, this is just an invitation to discussion.
Yeah, it'd be useful to get some more feedback on this. We did have a draft on transcending traceroute.
Yeah, my understanding that transcending traceroute was that you effectively get to NVE and query some information from there.
No.
No? Okay, I might forgot it.
The way it works is being able to, Eric, not Mark, is to be able to optionally set things up so that you run, for the purposes of these packets used to traceroute, which are regular UDP packets, whatever traceroute uses, for those packets, you operate the tunnel in uniform mode, not in pipe mode, meaning that you just copy down TTL and copy it back up. Meaning that your traceroute, the regular and modified traceroute gets ICMP errors back from the inside of the tunnel, the underlay routers.
Okay, so basically you expose the transit tunnel nodes.
Yes.
Okay.
And the knob saying, on the NV saying, should you do this, and which packets do you do to, etc.
Okay, thank you. Okay, then there is this scenario. Okay, and then usual invitation for comments and discussion.
Greg, quick question. So do you envision this echo reply and echo request support point to multipoint as well?
Okay, we looked at it on for beer use case as well, yes. So which is a point to multipoint.
Okay.
Okay, so again, can I get a show of hands on who's read the draft, please? Okay, a few more for this one. Be good, again, please send comments to probably the routing area working group list again.
Yeah, sorry, one other additional comment. Sure. So how do you propose this for the existing OEM, which we already have for different end caps, and are you proposing to replace with this, or are you proposing to work in conjunction with that?
One of their objective was that to make it transport independent, right? Because we have a lot of instruments for the MPLS encapsulation, which is LSV ping, in analogous to this one. In IPv6, so it's not clear how it will work. The idea was that, yes, we'll develop the comprehensive functionality, and then it would be optional to operators to choose which one they want.
So that means you're expecting a vendor to support both, for example?
Yes, if they will see this as an advantage that they can offer OEM toolset that works across different scenarios and different encapsulations.
Okay.
All right, thank you.
Okay, so now we're going to move on to the report backs from the discussion groups that we had yesterday afternoon, and the first one is Benson with the control plane discussion group.
All right, so I don't exactly know how we're going to do this, but I assume that people that participated in this conversation can stand up and point at things that I've said that are wrong or have more detail behind them. So please make this interactive. Is that okay?
Yeah, I mean, please, we've got 20 minutes or something for each of these.
Yeah, I have one slide. So
if you want to carry on the discussion at the mic, that's great.
Okay. So next slide. Move that hand up. Where?
Oh.
So we had a whiteboard. What do you call it? White pad discussion over here. Is that right?
Laser pointer.
Oh, it's okay. One of the first things that we, something wrong? No. Blue sheet problems. All right, sign the blue sheet. So one of the first things that we had as a discussion was sort of an open-ended question about what it exactly means to have a control plane in NVO3. There was some discussion about distributed control planes versus centralized, and management versus control, and so on and so forth. Sort of inaccurately, at least, but I tried to capture this notion that we have these things like discovery, management, and control, which happen at different points in time, and they change on different time scales. For instance, you have a set of activities, which I call here bootstrap and discovery, where NVEs, let's say they come online, they have to establish a relationship with an NVA. Maybe that's thought of as something you configure statically. Maybe it's something that your DHCP server tells you, but whatever. There's a bunch of ways you might think about it, but it doesn't change all that frequently. There was a discussion about whether that scales out if you have sort of one NVA for all NVEs, or if NVEs might, for different tenant networks, have relationships with different NVAs. And open question there, we didn't answer. Certainly, there's some discovery aspect, and I'm not really sure how to think about it, but if you have NVEs that have different capabilities, sort of the simplest way I can imagine that is maybe it has different QoS capabilities, or maybe it supports different NCAP protocols, or whatever. There's some kind of discovery that has to happen between the NVA and the NVE. So the NVE can perhaps tell the NVA can make decisions about how the NVE should behave, and so on and so forth. In a slightly more, so if that first category is really around bootstrapping, that happens in terms of the life cycle of an NVE, it happens maybe once until the NVE reboots, or there's some other activity that causes it to reestablish and rebootstrap. More active, you have a set of things that I think we categorized as management. There's a fuzzy line that we acknowledged between what's management and what's control plane. I don't have a really good sense about how to draw a solid line between those two things. But broadly speaking, we talked about the creation of a virtual network, which has a VNFib associated with it. You have to attach tenant systems. That's in many data center environments. That's a configuration or provisioning time activity. So it's not something that happens it happens more frequently than the NVE booting up, but it happens less frequently than, let's say, route changes or things like that. There was a comment as we started to wrap up. There was a comment about what we were really describing here being trying to capture a service model. So we didn't get into the detail of this, but one thing for the working group to consider is where there are already L3 and L2 service model Yang definitions, or whatever happening in other working groups we might be able to look at and leverage. There's some conversation about looking at the names for these things as they're used elsewhere so we can communicate clearly. Elia looks thoughtful.
So yeah, there's sorry, Elia Atlas. L3SM just finished up doing, and just closed, or is closing really soon. I don't remember. But anyway, they did a really interesting Yang model, which is really a service description saying, these are the ways you can attach, this is the type of topology you might have. It's not intended for implementation in routers. It's really sort of providing a model for the interaction between the customer and the operator who's providing that type of service. And so from the management perspective here, it could be quite interesting to do a model that said, these are the pieces to set up your virtual, the overlay in your data center, not this is the particular protocol and these are the particular bits, but the layer above that, partly because I don't think we have agreement on the particular bits, and the layer above that would still be interesting.
Yeah, I think one of the things that the control plane would need to deal with that's perhaps a little bit challenging is is dealing with migration and getting the changed information that that the other NVEs need moved around when migration happens.
Yeah.
I think just Lucy Yang from Huawei, just echo what Ali is saying. I also think that's interesting. For this NVA, for example, this northbound, we call this the operational data model, or we maybe call some, sorry, I saw the name, but I forgot. Yeah, that's it's not necessarily service model, because because service model here is a sense is a customer interface to whatever network operator they use in the term. But whatever this northbound interface, may be interested just for the operation or for some.
So, Elias, I think the point was that this is not at the level of the operational the operational model of this is how to configure and what that management interface is. I think that's interesting and could be useful too. But what I heard Benson was talking about was sort of the higher layer, the higher level abstraction, which would then boil down into that, but not trying to make technology binding.
Yeah, so at a level, sort of a higher level, one of the things that I hope we can take away from this, single slide is an understanding of where some work still needs to be done. And so the L2SM, L3SM, there are some examples we might be able to look at. Maybe they fit perfectly, maybe they don't. I don't know.
Right. My point is that whether this service model we're doing is for the NVA, particular, we call the NVA here, but industry may be called the controller. I'm saying that this controller, they have this the northbound interface that's applied to this technology area. We may
so I think because I might not understand what you just said. So what I think you're talking about here is something we tried to distinguish as a difference between management and control plane. So the control plane, as we tried to identify what it does, there's broadly speaking, there's a handful of things, but broadly speaking, as I've written on this slide at least, it's about reachability, which is to exchange the information that goes into a fib, and without talking too much about implementation details, that information needs to include encapsulation instructions. So you can think about tunnel definition and a fib as separate things, or you can think about them as one thing where the next top reachability information is an encap instruction, right? However we model that's I think what I just said is at the level of an NVA to NVE reachability control plane. So a controller, for example, might pass those types of instructions. Is that what you're saying?
Yeah, I think your wording here is very clear. What is control plane? Control plane is about the NVA to the NVE and the NVE to NVE. What I talk about is the NVA northbound. It's whatever they're talking to the service orchestrator, whatever. That's maybe some work interesting for this working group to do. That's my comment.
Sorry, Leah, Atlas again. So let me be clear. There's a lot of things that could be interesting. The question we have is who's interested in working on them and getting the drafts going. I think the control plane pieces have stagnated for a while. Obviously, there's fully distributed technologies that are providing a lot of this today in other contexts. And so one of the hopes from this discussion is to have you all find each other who are interested in the control plane stuff and start thinking about how to get things moving. And I really love the full mic lines. Thank you very much.
Hi, Greg Mirsky. I would think that this liveliness detection bullet, it might be function OEM.
I think so. Now, just to be clear, though, we did call out two different types of liveness detection yesterday. I made a comment about liveness detection being NVE to NVE, data plane liveness detection, and someone said, well, we also have NVE to NVA, and so I don't know the answer. Maybe you have BFD in one case and you have some control plane thing in the other. Maybe the in-band OAM is useful in one context but not the other.
Yes, I agree, because from our experience, we first had this functionality as part of routing protocols, would it be IGP or EGP? But then we found that they cannot provide really aggressive detection if need to be. So yes, let's see what the requirements and how aggressive we need to be, and then we can decide whether it's a function, whether it's a part of function of control protocol or it needs to be a part of OAM.
Yeah, I agree with that.
So, Nabil Bitar, I mean, just a couple of comments on what has been said. I think, if I recall correctly, Benson, that the reason that we went through this, that we want to define first what kind of things we need to do over the interface between the NVA and the NVE. Then that's what led us to divide into management and control plane functions that need to be done.
Yeah.
I think I agree with you. I mean, sometimes it blurs a little bit about what's management, what's control, and to a large degree, but I think at least this is the first kind of division. I think what Lucy is raising is the interface that comes from the NVA towards a client, if you will, of that, right? That's the northbound interface, which kind of was out of bound of the discussion yesterday, at least, right? Because we're talking about the southbound interface from the NVA to the NVE. I think given that we need to get something done, or the group needs to get something done, it's good to bound it to that. Along with that, you could define the service model, and maybe at the later stage, or we call it service model, whatever we label it, and maybe later stage, you could talk about how you want to communicate that to the NVA on the northbound interface. But at least bound it a little bit in early days and say these are the things that need to be defined, need to be done. We could borrow from other working group how these certain things are being defined, whether it's NetMod or other groups, and we define it that way. And later you could talk about how you could communicate that to the NVA. To go back to the OEM, I think functionality, we talked about configuring the OEM endpoints via management, right? That's one thing. Then we divided, I think, the OEM function about liveness between the NVA, the NVE that you mentioned in here. Whether I don't think we kind of necessarily need to label it as control plane, but more or less to say, is the NVE able to reach the NVA or vice versa, so that it could either pull information and it needs to affect forwarding, or the NVA could push information to affect forwarding as a control plane function. But really, whether the reachability between the NVA and NVA and NVE exists, that's really what kind of the liveliness part of it is, reachability in that context. I think there is no need really to get into this work about what kind of OEM you do, because that should be going on is on. But what comes back in here is that how you configure the OEM functionality that you need to exercise will come back in here. Not necessarily the OEM itself that says, how do I do for overlay or underlay? Yeah. But rather how to communicate it between the NVA and the NVE to configure it, to trigger it to happen.
Yeah, so you made 2 points. I'll address the one you just said first. I think that you're right. The OAM definition and how it behaves happens sort of orthogonally to the control plane. We probably have to talk about what the control plane does in response to, use the word trigger, right? Triggers from an OAM plane. And it's not always clear to me what that means. There may be connectivity between NVEs, even if one of them can't reach the NVA. There's a bunch of things like that we should just think about.
I think whatever that functionality is, what the NVA needs to enable on the NVE to trigger in-band OEM, if you will, right? That's what needs to happen. Now, you're configuring whatever that OEM functionality is supposed to be doing. I think that's really what, or enabling, if you will, is really what needs to be done in here, not necessarily the OEM itself. Yeah. And there are different things to be done. I think back to the management and control plane, which is kind of the tricky part. I think if you have very static environment, right, where endpoints, what we call TE, I guess, in the framework for NVO3, are pretty much static in nature, you could actually, configuring the routing context, all that stuff could be considered to be a managed function. That I create the routing context, I create the attachment circuit to it. I could push policies that apply to that routing context on that NVE, and the rest, which is IP reachability information that's pretty dynamic in nature, it will be pushed via control. And we talked, I think we focus on the NVA control plane separated from the NVE as opposed to distributed control plane. Now, the trick comes in that if there is very highly dynamic, I shouldn't say the trick, but meaning where kind of it becomes blurry a little bit. If you have very highly dynamic environment, like you have containers or you have VMs that come up and die, where you have, as whatever the things get created at very high rate potentially, you need to push into that forwarding context, again, VRF, EVI, whatever it is. You need to push reachability information, right, including how to reach, meaning over what tunnel you need to, or what kind of in-cap you need to use to get from this to the destination, or the host, or whatever, the first, the Tor, or whatever that's hosting that, the NVA at the endpoint. And then the policies associated with that, right? I mean, I don't know. I mean, this could be defined part of the service, definitely as part of the service model. Then maybe at some point there could be discussion about, do these have to be communicated over a management interface or over a control interface? I think that could be a discussion, and could be in both, actually, depending on the scenario or the situation or the use case, whatever, again, we call it, that needs to be satisfied.
Yeah. So I like the idea of having the working group at least talk about and understand the static routing equivalent of, to put words in your mouth, you could configure and run a network with nothing but static routes. I know people that have, and whatever. It's easy to understand. It's horrible to operate, right? But if we understand that, it might expose some things we can, the way we need to treat the dynamic control.
All right. Thanks.
Your other comment, I just don't want to miss it, is that, Lucy, I did actually misunderstand what you meant at first. I understand it better now. And,
yeah, that's why I was trying to clarify.
Yeah, thank you.
Parviz Yagani. I guess I need some clarification on the relation between the service model, the controller layer functions, and of course the NVA. The NVA, like today, if you really look at the platforms that are currently being developed in the industry, in the context of like SDN controller. Now, if you put that controller layer synonymous to NVA, is that the intention here? I guess Lucy just briefly mentioned that. Is that the intention here, that you want to really use NVA to basically capture the functionality of the control plane set of functions, control layer? Is that the intention?
Yeah, so I think if I try to recall the conversation that this working group had, a few years ago when we started, the way that we imagined it is exactly that the NVA is a controller. It pushes reachability and manages. Right now, the word controller might carry some baggage with it. People may think when they hear controller that we're talking about specific implementations, OpenFlow or whatever, and I don't mean it that way. I will also say, though, that at least in the conversation we had yesterday and some other conversations I've had recently, it's less clear that we should think of the NVA as only a controller. It also has some what I would call management responsibility in a life cycle of a virtual network. I don't know if those need to happen in the same place or if they're separable. I honestly don't know. I think it's something for the working group.
In the industry, this is, again, my view coming from not necessarily from an IETF perspective. In the bigger industry, if you really look at that, the train has already passed. This orchestration layer is different from control layer. So if IETF wants to reinvent a new architecture to basically bring the orchestration layer and controller layer into a single functional layer, I don't know the purpose of that, if that's the intention here. Okay, if that's not the intention, then the orchestration layer is not necessarily co-located with the controller layer. So orchestration is different. Then there is a notion of, this is very important, there's a notion of dynamic service configuration and dynamic device configuration. There are two aspects. You have the service model there, but I don't see the dynamic configuration of it. Is that a part of the configure control plane option? Is that what you want?
Well, so you're raising a good point, and I don't really know the answer, but if you think of an NVE as a device, it may be a virtual device or a physical device, but whatever. The configuration of a tenant, the fib associated with the tenant, the VN fib, to configuring those things are device configuration. They clearly relate to the orchestration. You have to configure those things as part of building whatever you're orchestrating. So I don't know.
No, actually, I disagree.
Okay.
The orchestration layer is different. The CRUD operation, CRUD, that we mentioned yesterday, that primarily belongs to the orchestration layer. Okay, lifecycle management. The controller is not in the business of doing lifecycle management. Today, my understanding, NVA could be a different thing. Okay, then you have the service configuration aspects. I guess I don't see it. Where is the service configuration aspects? Not device configuration. There are two separate things: device configuration versus service configuration. So we are doing both of them as we speak somewhere else. It is part of the OpenStack. It's a part of the Open ONUS. It's part of ODL. So that is already happening. I want to make sure that IETF is going to complement that. Because I guess someone mentioned yesterday, for IETF, I guess even Nabil mentioned that, the interaction between the NVA and NVE, if there is a need that for IETF to define a new protocol or protocol extension, that is the target for this working group, correct? That is the way I see it, IETF. It's part of one of the new tools that we need to really go back to the industry and say, you know, if you're defining the southbound interface, there are too many of them because your NVA could be from a different vendor, yeah? It's a physical box.
So my opinion, just to respond to the words you just said, my opinion is that there are too many of them, and it's not clear from a standardization point of view how we would build an interoperable NVO3 network.
I couldn't agree more.
Yeah. So from my point of view, that's a question that we have to answer here.
Okay.
You've raised some other points that I confess I don't know the answer. I hope
Aliyah has some bigger picture view.
Sometimes she has opinions.
Aliyah, well, I try. Sometimes I have a bigger picture because I have a lot of people who come and bang it into my head very carefully, and I appreciate getting that insight because you all have different perspectives. So one of the things is, yes, OpenStack, other places, this stuff's happening, but we need to get the interoperability is part of the problem. So one of the questions is bringing some of that here, in having an informed feedback loop and communication. This morning we had a routing open source meeting talking about, you know, how to facilitate and improve the interactions between the routing area, the IETF, and open source. This is one of the things that would be really good to do. And those of you who are active in those communities, think about, you know, how can we interact better? Can you bring some of the pieces here? What parts are stable enough that you think we could be talking about standardizing? No matter what we talk about, we've already had this discussion about how there's always pre-standard implementations. There really are always pre-standard implementations, but that's the running code that helps inform and help us pull together a standard.
Just a quick follow-up. I want to see the management function moved into the orchestration layer, if that's what you mean, to do the CRUD operation, CRUD operation. That doesn't, huh? So. Yeah, okay.
I think that's
at least here. The second point I want to make sure is to expand on service model. The service model is different from the dynamic configuration of the service itself. So we have that example.
I'm a little bothered by the word service because it can mean something different. I think
you can define the service, that's okay. But you already put service model there, yeah?
Yeah.
So then we have the dynamic configuration of the service.
I'll call that a mistake for the sake of the conversation.
Then we have a third item, which is the dynamic configuration of the device. We need to recognize that those three concepts, they exist. That has to be captured somewhere here.
Alisa, Jesse, to me, it seems like there is some confusion with respect to the scope of the work. We talk about the orchestration and lifecycle management of the VM and workload. That's, to me, is, you know, in my opinion, it should be outside the scope of this work. What should be inside the scope is basically the management and control for setting up the overlay layer. Okay, overlay in the simplest form with respect to the NVO3 context is VLAN. Okay, you extend the VLAN, how you configure that extended VLAN across this network, which is heterogeneous. Okay, it spans a bunch of data centers, core network, and so forth. Configuring that VLAN requires both management and control plane functionality. That's the scope. That's between NVA and NVE. That should be the scope, not above the NVA and you know, up northbound interface and all that. Limited to that scope. That is very clear. It matches the name of the working group, and we know exactly what to do.
And it matches our charter. So I agree with what you just said.
Okay, I think we're going to cut the lines off after people stand up. That's okay.
Greg Mirsky. I think that another topic for discussion would be to get a proper terminology in regard to what we consider to be static network, because what I think that once we have proactive OEM, and proactive OEM notifies NVA of the state of their network, then it's not static anymore.
Yeah, okay, that's a fair point.
I just want to comment. I think here we're having separated this management and the control plan. Then we are aiming possible this management, you have an interface, then the control plan have another interface. But if you look at this the new architecture, they have this SDN controller, basically doing both management function and some of this control plan. For example, for this NVA to NVE. Of course, this NVE to NVE it's a separate control. So that's not exactly aligned well, but some like a management function, like a configuration or this policy, certainly is carried on this the SDN controller. So
yeah,
that's a two-component way.
So one thing I want to say clearly, and probably won't say clearly, is that these are just labels that I assign to some buckets. And in those buckets, I put different things that have to happen over the whole life cycle of an NVO3 network. We can call the stuff that happens in what I call management right here, we can call that something else if that's what it needs to be called. Certainly, service model might imply something different to one person than another. We as a working group should, I think, talk about the life cycle abstractly and then figure out where some of these things fit.
Yeah, I agree. But a comment I want to say, I don't want to say in the back we are separating the define the component in this way. We are exclude something possible those components share the same interface. As I was saying, the SDN controller, you may just have the same interface, do the management function as well as this mapping.
Sure. Yeah.
Very short comment. Jackson, sure. So rather than trying to debate what service model means, we could take a look what's done in TS to some degree, and ITRS. It has very clear definition exposing APIs to provide business logic configuration. It doesn't do any configuration. It's meant to absorb business logic and do something southbound of it. So why reinvent the wheel? Definition is there and it works extremely well.
Well, and I probably used the term wrong on this slide. So I agree. All right. Thank you to everyone that helped with this discussion yesterday and here at the mics.
Yeah, thank you. So next up is Pat. I'm just giving me a minute or two to get the slides. Yeah, I didn't seem to have. Did you put it on the Google Drive? Yeah.
That's all right. I can. Yeah. Yeah, that's fine. That's good. Oops. Oh, it's a little.
Did I run it?
It just doesn't want. It doesn't like this angle. All right. We can fix that. Yeah. Sorry, I saved the thing with the wrong name and kept sending you the file with the right name and the wrong slides. Okay. NVO3 data plane discussion. Had a really good active discussion. Next. So we discussed some of the extension types that people feel there's need for. These are kind of thought starters, and you can find examples of some of these extensions in the GUE or Geneva drafts. Next. So there's been a lot of discussion about whether extensions are really needed or whether they should be handled by having interior protocols and just other protocols that are inside our header in the packet. I mean, farther in the packet than our header. And so we spent a lot of time discussing discussing why extensions are desired and kind of how we want to deal with them, how we handle them. So one point is that the extensions should make it easy for the devices that aren't processing the extensions to skip over the extensions and get to the inner encapsulated packet. And so people like having a length field there that's the total extension length, so they don't have to process anything else in the header to figure out what's there or go through the TLVs to get through there. And then, of course, it's also important to maintain 4-byte alignment. The existing drafts all do, so I don't think there's any issue there. And it should allow for some extensions to be critical. We talked a bit about what devices need to process some extensions, and the extensions, and are the extensions kind of just there for the end nodes, or the NVEs, or are they there for also things like the vSwitch and gateway and transit nodes? And there are some examples of extensions that may be in there to help the non-end nodes. For instance, tunnel stitching extension to help a node, an NVE that's at the edge, know what to stitch, what the next tunnel is. Extensions for non-end devices should be placed earlier in the packet, closer to the NVO3 header, so that the nodes in the middle of the network don't have to process through the list to get to them, but they can get to them in the first bytes they see. Okay, next. And then there were some questions. One was whether the extensions need to be carried end to end. In some cases, the extensions are carrying metadata that they want to go with the packet. So if you want them to go like between two halves of the split NVE, or between two overlay between NVO3 networks that are separated by another kind of tunnel, how do you get that information across? Is that important? So there was some discussion about that. It's something maybe somebody wants to do a draft to explore, or we have some discussion on the list to explore. Security. Does the header, is it desirable to have separate protection for the header so that the header can be checked for integrity and decrypted if it's encrypted without processing the whole packet? And so that was a discussion we had. I don't think we reached a final conclusion on there. Is criticality based on extension type, or is it always, in other words, if there's a particular type of extension, is that extension always critical, or is it something that varies based on the situation? And then upper bound on the extension size that the devices can deal with, and then whether that's 128 or 256. Didn't come up during the discussion, but I did hear somebody asking when we were talking afterwards about what's included in that? How much of the overlay headers are included in that number? Is it just the extensions, or can you go out to 120, the full 128 with extensions, or do you also have to take into account the other headers that we're adding, like the UDP header and IP headers and etc. Okay, and I think I have one more slide. Yep. So we spent most of our time on extensions because that seems to be where the biggest difference in viewpoints was. But we also did briefly touch on VNI size and whether 24 bits is enough, or whether something bigger like 32 bits should be accommodated. And so that's it.
David Black, apologies I couldn't be here yesterday. Did the security discussion distinguish between security of the header and integrity of the header?
The security discussion was about security of the header, but we did have in the extension types a header checksum. So
good enough.
I think my view of the room was that there wasn't any question that if we were doing extensions, people could see that you'd want a header checksum extension, so that wasn't discussed. I did get the feeling that, at least among that segment of the group that was there, we started getting some more comfort and closure with the fact that we probably need to have extensions, and so that it's more about how do we make those extensions so that they are friendly to the hardware that needs to either process fields after the extensions or process some of the extensions, than about whether there should be extensions or not. Anybody who was there and wants to, it wasn't unanimous. There was some dissent on that, but it seemed like we were building toward a good consensus on that, I think.
Pat, Sam from Google. Quick question. What was the next step you discussed? Like, how do we take it forward? What are the things you would like to see that should be discussed going further, versus what are the things which you think which are already resolved from the discussions?
Yeah, so I think a couple of things that I put early on in the slides where I thought there was pretty good consensus were things like that we need a length, and we need a way to say some of the extensions are extensions that should go first because they're extensions that are more likely to be processed in hardware, and there was definitely a pretty strong input to especially put the any tunnel stitching extension in front. So I think basically at this point it'd be good probably to get some discussion on the list about the exact nature of the extensions and what data should go with them. Probably something about another area that we need to build further consensus on is kind of how much flexibility do we need for extensions. Now we had consensus that there needs to be support for vendor dependent extensions, but kind of what size, how much in the way of extensions do you need to allow for, kind of that can be accommodated as standard extensions, and exactly what extensions we want to standardize, and I think those are things to go at with some additional discussion on the list and some drafts.
This question is to the working group at large, because we had multiple simultaneous discussions and people who are not part of the data plane discussion. So do you think most of the things which you would like to see were covered? If not, do you have any things you would like to bring to the working group?
So I have to confess that, Nabil Bitar, that I haven't been following all the data plane in-caps that have been carrying out their state, at least. So I know what's going on, but not exactly. But I think today we're talking about a lot of abstract things, right? I mean, extensions and what extensions we need to define, all this stuff. Don't we have already, I think, something that we could go with that allow us to extend without really dwelling on what the extension is? So I don't know really what, for example, tunnel stitching extension is. Today we jump from one tunnel to other by doing, go back to the service layer and do a lookup. The practical thing that we need is to be able to load balance, to carry things that allow us to change services. And along with that, I mean, so what I'm trying to say is that rather than keep dwelling on this problem or what data plane we're going to standardize or whatever, why not look at the other way to say, I mean, there have been, I think, at least a couple of data plane requirements draft that circulated around also at some point. Some of them was reaching conclusion, then reopened again. What I'm trying to say isn't worth to step back and say, what is really the minimalistic set that we need to get done, rather than standardize on something beyond VXLAN, because that's the mostly deployed, and then define that and move on. And maybe at later time you come back and talk about what other extensions we could define, what other extension we could standardize, all the stuff, because otherwise I think it's too open still. That's how the feeling I'm getting right now.
Well, I think that's kind of the point of this discussion, is to try and work out what that minimum subset is. That absolutely needs to be standardized.
Right, and if you go back to the page that I went over fairly quickly, which was you know, these are examples of some of the extensions, and if you look at these extensions, if you look at the GUE draft and the Geneva draft, they each have some of these extensions actually described in there. They have formats for them. So I think, you know, we do have some drafts with some specific formats suggested and specific information to be conveyed in some of these kinds of extensions. So I think, you know, there is that concrete thing behind it, and we have talked a lot about whether we should have extensions or not in the debates, but we haven't, I think, had as much discussion about the details of the extensions that are there,
and that's why I'm
proposed, and what they are and what they should be, and that's a good thing to bring to the list. Look at the extensions that are in the drafts now. Do they look like the right sets? Are some of them reaching too far, or do some of them not have the right information in them, and comment on them?
Right. So let me probably kind of try to parse maybe my question a bit more, my own question. That I'm saying that without worrying, I mean, do we have already, if we say NVO3 data plane protocol, can we name one today? Can we name two today?
So, Nabil,
Well, I mean, whatever. I mean,
so let me tell you where we are with the data plane. Well, actually, I guess the chairs could too. Do you want me to, or?
Go ahead. Yeah.
Sure. So we have a design team with a charter that was discussed on the mailing list and also in a virtual interim that expressed the consensus of the working group to standardize a single data plane encapsulation, and the design team is working from the existing encapsulations to handle the technical objections. They're working quite hard. I reluctantly gave them until the end of January in order to produce a version that we can look at. As part of pulling that design team together, I and Matthew and Sam talked to a number of people, not everyone we probably should have. And one of the points of confusion and debate and disconnection, I would say, is what was meant by extensions, what needed to understand them, what what parsing would need to be done by underlay routers, by transit routers, what parts in the stack needed to understand them. If we need to have flags so we can get the correct behavior at different devices, what levels and types of flags do we need? And that's part of what the discussion that Pat was leading was trying to poke at. Does that help?
It does help. So what I'm getting from you, Aliyah, that the path to define a data plane protocol, if you will, is already taken off, where there is already a team working on that. So we're trusting that that will happen in some way, although it hasn't happened the past 4 years, but I think hopefully it will happen by January. And that, just correct me if I'm wrong, where I'm wrong. So I see that already it's taken its path. It's your trusting is going to happen. And now we're opening up the next step before we finish the first one to say what are the extensions are. Maybe what I was trying to say, let's finish the first one and know that we could define extensions. Once that's finished, then you start talking about extensions.
I think the thing is that the data plane descriptions include things that affect how much extension you can carry and how the extensions are carried. And we need to pin down some things about the extensions before we can finish defining the data plane. And also, I think to get a one data plane and have the group be happy with the conclusion, we need to build some consensus about what the data plane needs to do to carry those extensions. And that's what this work is towards, is the extensions are built into the data plane as far as a way to carry them, what the structure of the header is that supports those. And we need to have some concept of what we're carrying to not over-design that or under-design that.
So, Lucy, if I may, I want to follow up on that. I know she's standing here. She has to say something. All I'm trying to say right now, why not say that the protocol, whatever we define for INCAP, allow us to carry extensions. Maybe the length matters, but not worry about what the extensions are. Define them later. That's all I'm trying to say. The extensions, make sure that the protocol is flexible enough to carry extensions, to define them later. That's all.
Right, but we need to. So, Nabil, I hear your point. The question is, for instance, in the Genève draft, there's a single flag saying extensions are critical. Who's it critical to understand? Is it critical for the transit to understand? Is it critical for the end systems to understand? Is it critical for the offloading NICs to understand? And so that drives what flags make sense to have potentially in the extensions. And if we have, so getting as much understanding of what those look like is the goal, not in any way, shape, or form trying to gate the data plane encapsulation design team's work on nailing down the extensions, because that's not happening.
Okay, I need to cut it off after Lucy, and then we'll move on.
Yeah, I just want to, I think, yeah, I think then what Nadir said, exactly what we're discussing goes through this exercise. Here we just list the examples saying the possible you can be the extension. So the basic, if we are designing encapsulation protocol, we are basically these things, we need that protocol be extensible so we can live longer. That's basically just message. We're not saying this is the things we're going to be, design. Yeah, exactly. That's what we're saying.
Okay, thank you.
At least use this version when you upload.
Yeah, I'm not on my email.
I can talk it over.
You can talk it over, can you? Yeah.
Okay, so in our own corner, we discussed OEM and what interest dependencies, requirements from OEM towards data plane and control plane. There could be what we see and where the work could be. Okay, so in a data plane, so OEM is required to be in-band, because then you can do easy correlation between their detected defects and performance measurement results with what experienced by the data flow. And there are different ways to ensure that OEM is in band, whether it's could be passive OEM in context of RFC 7799, could be active OEM, or in between, what we already today mentioned in situ OEM. So in order to do this phase sharing, entropy derived not from the payload, but expressed in a tunnel encoding. Because if it's entropy derived from the payload, obviously we cannot ensure, or it's very challenging to ensure that OEM will have the same information. One of the examples, like in IPv, we have 5 tuples. So for that reason, there is no protocols that do phase sharing, or actually it's very hard to do phase sharing. OEM identification as payload is unambiguous and is the same way, in a manner, as identification of the time of a payload. So to be more specific, we would prefer to have to use the protocol type rather than some dedicated flag. Okay, and no, can we go back, because yeah, so there is one point that I missed in these slides, but it's in another version that will be uploaded. In IP performance metrics group and in other groups, we presented and discussed use of alternate marking method, or a method that can be applied in a passive manner, so that changing some information in a header would not change their behavior of the packet. So thus, we can have an instrument to identify batches or specific packets and do loss measurement and latency jitter measurement using these markings. In earlier this week, there were 2 presentations and IP performance metric working group, and the base document is progressing nicely. There will be a working group last call, and then there was a presentation on a new method that introduces a different way of managing the markings. But the idea is that we would appreciate the consideration, and so that their header, data plane encapsulation header, to have a field which is not used, not affecting the treatment of the packet by the network. So thus changing its value would not change the behavior of the packet. Next. So for the control plane, one of the scenarios that we've been asked to consider is when the tenant tries to find MTU, path MTU, do path MTU discovery. Normally that probably would be a few challenges that needs to be considered in if you go from one data plane to another data plane. But there is another challenge that probably is not that, at least in our discussion, we came to that scenario later, and that is scaling. So when we have a massive number of tenants requesting it, and then it might be exaggerated because of rate limit control. So probably that could be a part of functionality that's supported by their control plane. So the tenant requests path MTU discovery from NVA. And that's something that another way to address it. Okay, and the next slide. So we discussed what could be next steps, and we agreed that those interested in this work will be able to sign to the NVO OEM list, and possibly, and to work on some solutions, one of them being this MTU discovery scenario in different variations. And at the same time, we see value on finalizing the requirements, because even though we might decide not to publish this document at some point, it will be helpful for us to have as a checklist to verify that solutions that we come up do satisfy their use case scenarios that we identify. And it's good to have it handy and to progress this work.
Question. I'm curious why you wanted to set another mailing list just for the OEM. NVO3 mailing list is very quiet. It's not much.
Why?
Yeah.
Again, after, okay, I expect that after this meeting, there will be a lot of discussion on data plane and control plane. Again, this is option. You know, we are not commanding to do that. If
yeah, I think it would be.
If community and chairs suggest to use generic list, we'll use the generic list.
Let's keep it on the working group mailing list for now.
No problem.
Then we get the maximum visibility of it.
Of course. Okay.
Tal Mizrahi, Marvell. You mentioned the alternate marking method. So one of the things that was mentioned yesterday in the data plane discussion was that we may want to allocate some bits in the encapsulation for the purpose of OEM. So I think you make a good point here, and this is certainly something that should be considered in the encapsulation, allocating this field in the header for alternate marking or for other OEM related purposes.
Yes, thank you. That's exactly, we not specifying what it will be used for. We'll discuss and provide their proper justification. But for now, we identify it as a field that does not affect treatment of the packet by the network. So it's not used as a TTL, it's not used as a class of service expression. It does not affect their forwarding decision.
Thanks.
Quick check to make sure I understand. PMTUD is being used as an abbreviation for a problem to solve, as opposed to a particular solution using DF.
No, it's a path MTU discovery.
Okay, by any means, which may or may not involve the DF bit. Well,
Basically,
what I got to say here is that
before the meeting, there was a agenda that outlined some scenarios that might be discussed in regard to path MTU discovery, and one of them is heterogeneous tunnels, data plane.
Right. There's also all kinds of problems with nested tunnels. Basically, what I got to say, and I think Elia's nodding around agreement, is that MTU discovery needs to be solved. It looks like OEM packets to probe MTU between tunnel endpoints might provide some leverage over a bunch of known nasty problems with DF, and figuring out how to do this without using DF would be a good thing.
Thank you.
And then beyond that, I think the other thing is just a general pointer over to the Inter-Areas tunnel draft, the Inter-Area Working Group's tunnels draft, which has done an awful lot of work on this and some related fragmentation. And there's a few details that, if you get them right, make the problem considerably simpler for traffic going over the tunnel.
Okay, great. If you can send just direct reference to the document, I'll greatly appreciate that.
To the mailing list, sure.
Yeah, thank you. Thank you.
Okay, thanks very much. I'd just like to say thank you very much once again to our facilitators for an excellent set of roundtable sessions, and also to Aliyah for helping coming up with the idea of this in the first place and helping to make it work. Yes. Yeah, please let us know if you found this a useful exercise. I know it's kind of different for an IETF meeting to do this. It's a bit of an experiment, and we didn't really know how it would go. But I think from our point of view, it's been very valuable. So please do go ahead and write drafts now. If anyone hasn't signed the blue sheets, they're up here. Thank you.
Sure, why not?
Yeah, yeah, I know.
Thanks for
Ahead of time, so
yeah,
I was
well,
really pleased.
thank you.
Yeah, so I think that's the exercise which was being done in the last 2 years. Cool.